section 3.2, what we're going to do is get into equations that are just a little bit more complicated, or there's a little bit more to them, more steps, because before we talked about there being two-step equations. And, two-step equations is a simple way of getting it to there, or getting to the point where you want to solve it. But for these, we don't really have three-step or four-step equations. We don't really call them that. We just call them multi-step. So the first part of your notes here includes steps for solving linear equations containing variables on both sides. Now, the first thing that I want you to write down, you can pause the video and write this down while I'm talking about it, but if needed, and I think the first three things here is always if needed. It's not always something that presents itself, but it's a lot of times it is going to be something that you'll have to do. But if needed, if it presents itself, clear parentheses by distributing on both sides. So for both sides of the equation. So that's your first step, okay? Your next step is to, if needed, clear fractions by multiplying all terms by the LCD. Oops. And then I'm going to go ahead and just go ahead and uncover all this. I'm trying to be clever there, and it didn't really work. But number 3, if needed, clear decimals. Number 4, combine like terms on each side. And number 5, apply inverse operations. And I want you guys to make a mental note, at least for right now, because these rules are kind of all hard to follow just by looking at them all together. But I want you guys to pay attention in particular to number 5. Now notice on number 5 that the very last thing that is mentioned in this whole process of solving these kind of equations is inverse operations. That's the very last thing that we have to visit there. So apply inverse operations as your last step. I know a lot of times when people do these problems, they just want to get right on board and start doing inverse operations, but there's some simplification that needs to take place. There's some like terms that need to be put together. There's parentheses that need to be cleared. There's fractions and decimals that can be cleared out. All right. But the last thing you're going to notice, the last thing you're going to do is put or is to use inverse operations. So that's something to keep in mind. All right. So here, let's get right to it. For number 1, we've got 2v plus 15 plus 3v equals 3v minus 10. So a lot going on in this problem, but let's focus on each side. We're not going to do inverse operations yet. Let's just focus on the like terms that we can perhaps put together. So we have 2v and we have 3v on that side. That makes 8v. Okay. And we also have constants that can be, oh, no, we don't. And then we've got 8v plus 15 equals 3v minus 10. All right, so now we have variables and constants on both sides. So our point is, our goal here is to get variables on one side. So what I would do is I'm going to subtract 3v from both sides, because we're moving this entire term. We want to move 3v over. We want to get rid of it on that side. And in order to get rid of it, you got to do the inverse operation right there. So that's what's going on. And now we're going to rewrite it. Now we've got 5v plus 15 equals negative 10. So like I was saying before, every time you do a step, you're rewriting the problem. So important to do that. I can't tell you that enough. Always rewrite the problem. Become something else. Okay, it's very important that you write it down, see it, it's all rewritten. It doesn't hurt to write it down again. All right, from here, we're going to subtract 15 first. So what we do to one side, we do to the other. And the point of doing that side is to get those to cancel, which is what happened. And so now we got 5v equals negative 25. And at this point, it's a one-step equation. And all you have to do is divide by 5 on both sides. And that gives us at the end, b equals -5. And that's it for that problem. For number 2, we've got some parentheses that need to be cleared. Now before we clear them, let's make sure we know, well, when you clear parentheses, it involves what step? It involves distributing, right? We're going to use distributed property. So let's decide what's being distributed. So sometimes it's not totally clear. So what are we going to distribute into 4m minus 5? Very important, especially that part, to know what's being distributed. So we're going to distribute -1 on that side. That's what we're going to distribute. So -1 is being distributed. And over here, we're going to distribute 3. That's really not the hard part. I think it's important that you guys know that we're distributing a negative. And sometimes it's easier just to think of it that we're distributing -1. So let's do that. So I'm going to rewrite the problem. So 10m plus 13, nothing happened to that. So just drop that down. So -1 times 4m is -4m. And -1 times -5, a negative times a negative, is going to make +5, equals, all right, drop down the m, plus, and then 3 times m is 3m, and 3 times 7 is 21. Okay, so now we have 10m plus 13 minus 4m plus 5 equals m plus 3m plus 21. All right, so now we're going to put together like terms on both sides of the equation. So we have m's over there, and we have constants right here. So the m's, when we put that together, the m's make 6m plus 18 equals, and then on the right side, we've got m, and we have plus 3m. That makes 4m, because this is, you can think of that as 1m. So 4m plus 21. And now let's get the m's to one side. Let's subtract 4m. So now we're doing inverse operations. I always want to say order of operations, but we're doing inverse operations at this point. So we're subtracting 4m from both sides and rewrite it again. So now you have 2m plus 18 equals 21. And let's subtract 18 from both sides. Those cancel out. And then you have 21 minus 18. We'll write it over here. We've got 2m equals, and then 21 minus 18 is 3. And now it's a one-step equation. Divide both sides by 2. Those cancel. And then 3 divided by 2, you can just leave it that way. You can just leave it as 3 over 2. So m equals 3/2. And you could also write 1.5, or you can write 1.5. All of those would be acceptable answers, I'm sure, especially on Alex. If you guys are solving things, putting in any of those 3 ways would probably suffice. All right, for number 3. Let's clear parentheses like we did on the previous one. So for this one, we're going to distribute 2. And in the other fraction, we're going to, or the other parentheses, we're going to distribute -5. 7y drops down because nothing happens to it. 2 times 1 is 2. 2 times -4y is -8y. Equals 8y. And -5 times y is -5y. And -5 times 4 is -20. On the left side of the equation, we have some y's that we can put together. So the y's on that side, they make -1y, or just -y if you want to write it that way, -1y. I like to, even if it's negative, but if it's just 1, I like to put the 1 there. Plus 2, nothing happened to that 2 right there as of right now. And then on this side, we've got 8y, and we have negative 5y. That makes 3y minus 20. Okay, and at this point, we've got everything on the left side and on the right side of it simplified. That's what we want. We want, everything to kind of be worked out. So then that tells us that we can do order of operations. I keep saying that. We want to do inverse operations next, inverse operations. So let's go ahead and subtract 3y from both sides. So subtract 3y. Those go away right there. Those go away, and now we're going to rewrite it. And so now we have negative 4y plus 2 equals negative 20. Negative 20. So now it's a two-step equation. Let's subtract 2 from both sides. Those go away. Rewrite it again. So now you have negative 4y equals, and then negative 20 and negative 2 does not make negative 18. It doesn't make positive 18 either. It makes negative 22. So we're adding those up. And then one more step is to divide both sides by negative 4. So those go away right there. And now we're ready to solve it. Now here's a couple things here to point out. This one is a negative divided by negative, which means it's going to come out to be positive. So let's not even worry about that anymore. And then you get 22/4. Now 22/4 can be simplified. Let's not worry about dividing. Let's just simplify it by 2. And so if you simplify it by 2, you get 11 halves. And that's fine. I mean, if you want to write 5.5 or 5.5, you could do that. It doesn't matter. You can do it either way. All right. For the next part, we're going to get into something called clearing the fractions. Also, we're going to talk about clearing decimals. And I would say this is a pretty valuable skill. I would definitely suggest practicing this. I know sometimes people are like, can I just do it without it? And my answer to that is, yeah, I guess, but you're you're denying a good strategy that really is something that is helpful throughout, not just algebra, through every math class. I mean, just knowing how to clear out fractions in a problem is just a good skill. And I would recommend doing it. And the notes that I gave you guys for this one is to clear fractions. So you'll see that the next few examples here, the next 2 examples at least, have fractions all over the problem. Okay, fractions. So we're going to clear fractions from the problem by multiplying all the terms, okay, except what is inside parentheses. So you're going to leave what's inside parentheses alone. Don't touch it. Sometimes my students say like there's the force field around it, so they're not going to be affected by the multiplying of the LCD. And you're going to multiply every single term, not just fractions, but every term except what's inside parentheses. You're going to multiply everything by the LCD. So that's what we're going to do. So if we look at these denominators here, we have 9 and 2. That's the only 2 numbers we have. And the LCM or LCD of 9 and 2 is 18. It's 18. So we're going to multiply every single term by 18. So 1/9 gets multiplied by 18. 1/2, I can kind of squeeze these in here. And then 2/9 gets multiplied by 18. Now this part right here, don't multiply that. We're multiplying 2/9, which is not inside parentheses. Leave the 3n minus 2 alone. So when you guys multiply everything by 18, what that does is that cancels out the denominators for all the fractions. And that's what you want to happen, because a fraction is only a fraction because it has a denominator other than 1. It has other, when it doesn't have a denominator other than 1, like let's say that's 8/9. Well, if we get rid of that 9, right? If we get rid of that denominator, it's no longer a fraction, it's just 8. Okay, but it's not just as easy as just crossing it out, but it is almost that easy. It really is. It almost is as easy as crossing it out, but because we're going to cross cancel. So 18 divided by 9, 18 divided by 9 is 2, and 9 divided by itself is 1. And that's what you want to happen to every single denominator. You want to get a 1 here. If it doesn't turn into 1, you're not doing it right. So you want to get a 1. All right, this next one here, we're going to do 18 divided by 2. That's That's going to be 9, and this is going to be a 1. There you go. 18 divided by 9 is going to be 2, and this turns into a 1. And now, as of right now, it looks like all the fractions have been cleared. So now we can just multiply. So 2 times 1 is 2m. So you have 2m plus, and then 1 times 9 is just 9 equals, and then right here we have 2 times 2. So 4, and the 3m minus 2 was the only thing that was not affected by multiplying by the LCD. And then at this point, it's an equation that we have been working with. So let's clear the fractions, or clear the parentheses, I mean. Let's clear the 3m minus 2 by distributing 4. So we're going to distribute 4 into both of those terms. So let's go ahead and do a rewrite. So now we have 2m plus 9 equals, and then 4 times 3m is 12m. And then 4 times 2 is 8, so minus 8. All right, let's get m's on one side of the equation. I'm going to do it the other way around this time. I'm going to take away 2m from both sides here. Those cancel off. And I'm going to rewrite it. So now we have 9 equals 10m minus 8. 10m minus 8. And what are we going to do next? Now we're going to add 8 to both sides. Add 8 to both sides. And rewrite it again. Let's rewrite it again. So 9 plus 8 is 17. So you got 17 equals 10m. And that's a one-step equation right there. Divide both sides by 10. Divide that side by 10, divide that side by 10. And then 17 divided by 10 doesn't reduce like a fraction. We can just leave it improper, which I think is always the preferred way of doing it. So 17 tenths. You can write it like that. You can write 1 7 tenths. Sorry, that's kind of a weird way to write 7. And then, or 1.7. All those answers would be perfectly acceptable. Unless it tells you not to, but those are fine. And then, I'm doing another example for number 5, but, feel free to pause the video and try these on your own and see if you're getting these right. It's okay if you don't listen to every single word I say, but try these problems on your own, see if you're doing it. If you're doing it right, move on to the next part. So for number 5, what we're going to do is we're going to multiply everything by the LCD. Everything's going to get multiplied by the LCD. So the LCD of 3 and 2 is 6. So everything's going to get multiplied by 6. Everything. Not just fractions, but every single term is getting multiplied by 6. Everything. Okay, because what that does is that makes everything cross-cancel. So 6 divided by 3 is 2. 3 divided by 3 is 1. 6 divided by 2 is 3. And then this becomes 1. 6 divided by 3 is 2. And that becomes a 1. And now let's go ahead and just multiply what's left over. So we have 2m, 2 times m is 2m, plus 3, 1 times 3 is 3, equals, and then 2m times 2 is 4m. What happened there? Sorry. 4m, and then plus 3 times 6 is going to be plus 18. Plus 18. So you have 2m plus 3 plus 18. See, in clearing those fractions, every one of those denominators turn to a 1. And that's the goal. You want that to happen. So now let's do inverse operations. So I'm going to do it this way. I'm going to take away 2m from both sides. These cancel each other out and rewrite the equation. So you got 3 equals 2m plus 18. So let's go ahead and subtract by 18 on both sides. And 3 minus 18 is negative 15 equals 2n. Negative 15 equals 2n. And divide by 2. Because that gets the n by itself. Negative 15 over 2 is perfectly fine. Let's write that down in some answers. So m equals negative 15 halves. You can write down negative 7.5 as well. Or negative 7 and 1/2, like a mixed number. Every one of those ways is okay. Okay, for number 6, now this gets into this the process of clearing decimals. Okay, now make sure you write this down. I'm going to go ahead and talk about it. And what I have written down there for clearing decimals is that you want to multiply all terms, except, just like we did before, except what's inside parentheses, by a power of 10. Power of 10s are, 10, 100, 1,000, 10,000. 50 is not a power of 10. That's a multiple of 10. That's not the same thing. So 10, 100, 1,000, 10,000, 100,000, a million, 10 million, 100 million. So it's got a 1 followed by zeros or preceded by zeros as well. So multiply all the terms except what's inside parentheses by the power of 10. And then that will clear the decimal with the most digits. All right. So you want to look at the problem here, and you want to find the decimal that has the most digits. So this one has 1 number after the decimal place. This one has 2, and so does this one. All right. So the number that has the most digits, the decimal that has the most digits, is going to tell you what to multiply by. So multiplying by our power of 10 is what it does is just moves the decimal. We're going to move the decimal over one place if we multiply by 10. If we multiply by 2, we're going to move over, or multiply by 100, we're going to move the decimal over 2 places. So 1, 2. So we're going to multiply every one of these by 100. 100. So this gets multiplied by 100. Everything gets multiplied by 100 except what's inside the parentheses. And when you multiply everything by 100, what happens is the decimal moves over 2 places. So that becomes 20n minus 15, n plus 4, unchanged, equals 25. Okay, so went from an equation that had everything decimals in it to something that did not have decimals. Okay, so that's just kind of point out what happened. Every one of these problems, we moved the decimal over 2 places. 2 places. The decimal was here, and then it moved over 1, and then 2. It moved right there. So if it's a whole number, it's there. We know it's there. Right here, this moved over 2. 1, 2. This also moved over 2. 1, 2. So now let's clear parentheses. So you got 20n minus 15n minus 60 equals 25. Right here, those are like terms. Let's go ahead and clean those up. So that makes 5n minus 60 equals 25. And then we're going to add 60 to both sides. And now we have 5n equals 85. So we're going to divide both sides by 5. Oh, I just noticed something. No, I didn't. I thought I did something wrong. If I did, just let me know. Divide by 5. And those cancel off. And so now you got n equals 17. For number 7, the number with, or the decimal with the most number of digits after it is the third one right here. This one that has 3 numbers past the decimal. So that means we're going to multiply everything by 1,000. Every single thing is going to get multiplied by 1,000, except what's in parentheses. So that means we're going to move the decimal over 3 places for every one of those problems. So then that becomes 100x plus 150. And then 8 minus x equals 125 times 8. And the decimal, like I said, the decimal moved over 2 places or 3 places every time. Moved over 3 places every time. So just to kind of point out what happened here, the decimal was here, then it moved over 3 times. 1, 2, 3. So now it's there, but you don't need to show it if that's where it is. Okay. So the decimal was right here. Decimal was there, and then we moved it over 3 times. 1, 2, 3. So 150, that's where the decimal is. The decimal was here. It moved over 3. 1, 2, 3. That's all that's going on there. Okay. Now let's get down to the business of solving this. We'll clear parentheses by multiplying by 150. So 150 times 8 is 1,200. 150 times x is 150x. And then 125 times 8 is 1,000. We have a like term 100x and negative 150x. That is going to be negative 50x plus 1,200 equals 1,000. There you go. And then we're going to subtract 1,200 from both sides. Those cancel out right there. Rewrite it. So negative 50x equals negative 200. And at this point, it's one more step. Divide both sides by negative 50. Those cancel off, and a negative divided by negative is positive. That's positive, so then you get x equals 4. Positive 4. Okay, so now the steps for solving equations with no solution or an infinite number of solutions, I want to get to that last. What I first want to do is let's go through the process of solving these problems and then kind of discuss what happens to make it have no solution or infinite solutions. Okay, so let's go ahead and just do that. And I'll point out where you kind of have to kind of keep a lookout for things. So let's just go ahead and go through this problem. We're going to distribute the 4. So I'm going to rewrite it. So 9p plus 4 equals, I'm going to write 1p. 1p, and then 4p, or 4 times 2p is 8p. And then 4 times 7 is 28. So minus 28. Now there's a little cleaning up we need to do on this side. We have a couple p's that need to be put together before we do inverse operations. So you got 9p plus 4, that's unchanged, equals 9p minus 28. And let's get the p's on one side. So we're going to subtract 9p from both sides, like so. And so now that becomes 0p. I mean, typically it becomes nothing, right? 0p, that just means there's no p's. But I'm going to write 0p plus 4 equals negative 28. And then let's subtract 4 from both sides. Those are additive inverse right there. And now it becomes 0p equals negative 32. And here's where I want to stop for a moment and just think about this, because if we divide by 0 right there, we're breaking one of the most fundamental rules of mathematics, which is we cannot ever divide by 0. Never. You cannot divide by 0. So that breaks a huge rule. Dividing by 0 is impossible. It becomes undefined. All right, which tells us that since we can't divide by 0, this has no solution. This has no solution. This is undefined. Okay, there's no number you can multiply by 0 that will equal negative 32. Just nothing, not even 32, not negative 32, not 0. 0 times no number is going to equal negative 32. That's an impossible situation. It's also called a contradiction mathematically. But yeah, there's no solution there. Okay. Right here in the next example, let's go ahead and just go about through solving this. So we have 3y plus 16 equals 5y, and we're going to distribute negative 2. So negative 2 times y is negative 2y, and negative 2 times negative 8 is 16. So now we have 3y plus 16 equals 5y minus 2y plus 16. And then these are some like terms we can put together. Now notice right here, we have both sides of the equation are exactly the same. 3y plus 16 equals 3y plus 16. They're both carbon copies of each other. And let's go ahead and get let's go through inverse operations here. So we're going to take away 3y from both sides. Those cancel. So do those. But I'm going to write, instead of writing nothing, I'm going to write down 0y plus 16 equals 16. And then subtract 16 from both sides. Rewrite it, and now we have 0y equals 0. Now, what this means is that this has infinite solutions. That's what's going on here. The number of solutions to this is unlimited, because any number multiplied by 0 is always going to be 0. So it doesn't matter what y is. Y could be absolutely anything. It can be 2, it could be 3, it could be 4, it could be 5. It could be negative, it could be pi, it could be anything. It could be, it could be an irrational number like square root of 5. It could be anything. So that has infinite solutions, plural. Okay, so let's go through the summary here. Outcomes when solving linear equations. What are the outcomes going to look like? Well, when there's one solution, it's going to look like this. Let's get down to the point where it's like, what I'm going to do is I'm going to show you, like, let's get down to a point where it's a one-step equation. All right. And when it's what it's going to look like when it's a one-step equation. So if you guys have an equation like this, let's say you have like 5x equals negative, even if it doesn't work out perfectly. Right there, that has one solution. That's like one of the first things we talked about in chapter 3. That has one solution. Now, it's not a very pretty solution, but it's a solution nonetheless. All right, now if it has no solution, it's going to look like this. It's going to look like negative 0x, not negative 0x, there's no such thing as negative 0x. It's going to be 0x equals negative 31. Because right there, that's a mathematical contradiction. So what I wrote down there was the variable canceled, but the constant did not. So that's what you're going to kind of look for. All right. Another way too is to kind of look at it this way. Sometimes you know, you might see it before it's just a one-step equation, but it might look like this. Let's say it's like 5x plus 1 equals 5x minus 6. Something like that. You'll notice that both sides of the equation are almost exactly the same. They both have a 5x. They both have a 5x, but you're going to notice the constants are not the same. So the constants, one of the constants is 1 and the other one's -6. So if it ever looks like that, you know, alternative way they're kind of spotting it out is that when both sides aren't exactly the same, they're almost the same, but not quite. And then when it has an infinite number of solutions, it's going to look like this. It's going to be like 0x equals 0. All right. So both the variable and the constant cancel each other out. Cancel out. So you have 0x equals 0. Alternative way of seeing this might be, you might see it like 5x plus 1 equals 5x plus 1. Right? Both sides of the equation are exactly the same. They're exactly the same. All right. For this last part here in section 3.2, we've got just steps for solving applied problems. And I just think, you know, the steps for these is just to make sure you go little by little. I would sometimes say slow and steady wins the race. I've said that before in math, but just kind of try not to look at the whole problem all at once. I think sometimes that's overwhelming. So just start from the left, work your way to the right, and just kind of bit by bit start deciphering it, okay, and translating what it's saying. All right. So right here we've got 7 more than. Now that's got that then in it. So 7 more than twice a number. Twice a number is 18. So when it has then in it, that means like we have to switch it around a little bit. So twice a number means 2 times a number. So it doesn't matter what you use for the number. You can use N or X or G or A, whatever letter you guys want to use. All right, 7 more means plus 7. So that's what happened there. Okay, so twice a number went right there, and then 7 more than went right there. Notice how they kind of were in exactly the same order they were written in. And the reason for that is because of that word then. That is tricky, I know, but just got to get used to it and got to practice it just so that you're used to it. Next one we've got, it says is. Now is a linking verb, just basic verb there, but is means equals, right? That means equals. And then equals 19. Now I know it says solve it, but I really want to just concentrate. I want to focus on writing the equation. I bet you at this point, hopefully at this point, solving these is not the issue. I think writing these out as equations is sometimes more of the challenge here. All right, for number 11, we've got 3 less than a number is 11. So 3 less than a number. Oops, let me do this. I'm ahead of myself there. 3 less than a number. So what that means is the number is n minus 3. Again, it's got that word then in it. It's got that stupid word then. Okay, and so we want to pay attention to that. It's right there. So a number, when it says a number, that means n or x. So 3 less means minus 3. 3 less than. Is means equals 7. So is means equals. All right, number 12, a little bit more going on here, but we've got 7 less than 4 times a number. So let's kind of focus on that part. So 7 less than 4 times a number. So, and it's got then in it again. So 4 times the number means 4n or 4x, 4a, 4b, 4c. 7 less means minus 7. Is means equals. Just want to keep pointing this out. When you have that then in there, and it switches stuff around, doesn't it? And it says is the same as that number. Is means equals. Now that number, we don't know what that number is, and we in the other side of the equation we used n. So we're gonna that number is n for all we know. We don't know what it is. Increased by 20. Increased by 20. Okay, and then like let's go ahead and solve that on your own. And then we have one more problem to do. It's take a while. And for number 13, a number added to 5. So a number added to 5 means n plus 5, or 5 plus n, because with addition order doesn't matter really. Is means equals, or more means plus 4, then 8. So you have 8 plus 4. So it's really n plus 5 equals 12. All right, so that concludes lesson 3.2 in your guide notes.